In the previous part, we started doing calculations for the hypsometric curve, where we starting working in ArcMap, and we divided the elevations in DEM map for the study area to 35 intervals, and these intervals starts from 128 to 3,600, and we obtained the area between intervals, and in this part we continue to calculate the hypsometric curve, where we go to Excel file prepared for calculating the hypsometric curve, and it has the first field titled NO number, which contains the number of intervals from 1 this field number contains number of intervals from 1 to 35, then we go to the field min and max, and we put in them the min interval and max interval respectively, as we see. Then we go to the average interval or average elevations, in which we calculate the average elevation for each interval, as we see. Then we go to the area field, which is area between intervals, which existed in this file titled hypsometric analysis, and in it there is an Excel file titled area, which contains the area between intervals, which is in meter, where we convert it to kilometers by dividing the area by millions, as we see. where we make a copy for the results and we transfer them to the Excel file, which is used to make calculations for hypsometric curve, and we make a paste for them in the area field. Then we calculate the cumulative area, where we start calculation from the last line of the field as we see. Then we calculate the relative area, where we start the calculations from the first line of the relative area field as we see. It should be noted that if the relative area value is less than 0.1, it is neglected when performing the calculations, as in the 4 lines in the relative area field. In the 4 lines, in the last 4 lines in the relative area field. Then we calculate area percent between interval. We start the calculation from the first line of the area percent field as we see. Then we calculate the interval difference, where we start the calculations from the first line of the interval difference field as we see. Then we calculate the level difference, which is equal the difference between max elevation in interval and mean elevation of the study area basin, where we start calculations from the first line of the level difference field, as we see. Then we calculate the relative height, where we start calculations from the first line of the relative height field, as we see. Then we calculate the hypsometric integration, where hypsometric parameter equal relative height over relative area, where we start the calculations from the first line of the hypsometric integration field, as we see. The final value of hypsometric integration is equal to the sum of the values in the field titled hypsometric integration, noting that the last four values are neglected, as we mentioned earlier, and the value of relative area is less than 0.1. It is neglected when performing the calculations, where we calculate the final value of hypsometric integration, which is equal to the sum of the values in the field titled hypsometric integration, except the last four values neglected, as we see. The final value for hypsometric integration is 73. This resulted value of the hypsometric integration, which is 73, and according to Strahler, who divided the value of the hypsometric integration into categories as follows, falls within the third category between 60 and 80, which represent the youth stage, and so the stage which passes by the study area basin is the youth stage. Now we start drawing the hypsometric curve, where to draw the hypsometric curve we draw the relationship between the relative area and average interval, where we activate the values in the field relative area and average interval. Then we go to the insert menu and in it we go to charts and we choose scatter. Charts appears, then we go to select data, then edit, and in series X values we choose the value in relative area field, and in the series Y values we choose the values in the average interval field. Then we press OK, then OK. The hypsometric curve appears, and in a chart title we type hypsometric curve. Then we add the axis titles in in x-axis we type cumulative area percent, and in y-axis we type elevation, which is in meters, So this is the final form of the hypsometric curve for the study area basin, which represents the relation between elevation, which is average interval, and the cumulative area percent, which represents the relative area. As we said, the final value of hypsometric integration is 73. This value, according to Strahler, falls within the third category between 60 and 80, which represent the use stage, and thus the stage that passes by the study area basin is the use stage. By this, we have completed the hypsometric curve calculation for the study area basin. Now we save the results of the hypsometric curve for the study area basin, where we click on Save, Browse, Desktop. Then inside the file titled Hypsometric Analysis, we type the save name, which is hypsometric curve. Then we press on save. Then we go back to ArcMap and we save the project by pressing on save. By this, we have completed the hypsometric curve calculation for the study area basin.